Hello, the title of our research is Cellular Manufacturing's Impact on JIT and Lean Outcomes, a literature-driven analysis. I'm Weng from Kanazawa University, Japan. First is the background of our study. Toyota production system and its just-in-time philosophy is a representative of lean production. It is reported to be superior in performance, such as inventories, lead times, and production costs. And the aim of this study is to let more manufacturers benefit from JIT and lean manufacturing. This is an introduction about previous research. We have investigated the literature on JIT philosophy from 1977, and we categorize the research studies into three types. One is reports and analysis. For example, there are reports about what is JIT, the concept, its advantages, and its characteristics, principles, and practices. Another kind of papers are surveys on JIT firms, companies. For example, what are the really received benefits and improvements from JIT? And what are their most important and effective characteristics and principles? And the third type is industrial cases. For example, they reported some examples of successful JIT firms. And here are the problems we found in previous research. The first is that the findings are inconsistent on the positive relation between certain JIT practices and success. For example, in this study, it reports that Kanban plays a significant role in JIT manufacturing. However, in the past, Kanban was said to be merely a way to make lot sizes visible, whereas the real contributor is small lot sizes. So whether Kanban plays an important role is not consistent in findings. Another example is that data of over 10,000 firms in the USA show that after adopting JIT, top performers got better and bottom performers got weaker. So there are many differences for each individual firm. So the finding makes it difficult to tell whether a certain practice will really bring some positive results. Another problem is that it is unclear where to start JIT because there are many elements or many characteristics or many should be done to adopt such manufacturing. So where to start is not clear. Here are some examples. In their study, they proposed 10 JIT practices, including quality circles, total productive maintenance, and etc., and suggested these individual practices can be introduced as separate programs. And in this study, they argued that production smoothing should be one of the first steps towards JIT. And in this study, it is found that JIT implementation should start from quality-related practices. So it is difficult to trace the start, where to start JIT is the best flow or the best practice. And the contribution of our study is to help solve these two problems. And what we have done in this study is first, we identified cellular manufacturing to have the primary impact on lean performance. So the conclusion is that cellular manufacturing is a good start to adopt JIT. And the second one is that we analyzed what CM is able to bring and why. So we can show you what benefits can be expected from adopting CM. So first we give an introduction about the details of cellular manufacturing CM. This is an image showing the CM manufacturing layout. It means the manufacturing on a shop floor divided into a number of work cells, each dedicated to making certain products. So for example, for product 1, it is made in this cell, product 1 work cell. And for product 2, it is made in this cell called product B work cell. And in each cell, there are many steps, each being one process. And the raw material starts from this place and then goes into all the steps and finally becomes finished goods. And it is still along this corridor side. And for product 2, it goes in this cell, in this flow. So the raw material and finished goods are also alongside this corridor. And then other products are made in the same way. And these raw material or finished goods are moved to be delivered to the next, for example, production stage or to the customers. And we want to introduce another kind of production, that is manufacturing factories that are not using CM. So this is one type of manufacturing, and this is another layout for common production. It is called functional layout. More traditional. This one is more traditional because it is suitable for making some small quantity products. And in this layout, machines are grouped together. So for example, this is the raw material area, and the raw material for all products are grouped here. And then the materials will go to the production area and then go to the package area. And in each area there are some machines, and each machine will be doing a step of the production process. And finally, the jobs becomes finished goods. So you can see that the arrows representing a product, they are going different, machine groups. And each group represents a kind of machine doing a kind of job, doing a kind of process, a kind of step. And then by going to different groups, then different jobs can all be produced in this area. And finally, they also go to the package area, and they may also go to different groups of machines. And finally, they are delivered to as finished products. So the difference is that here each product is grouped in one place, but here each place is grouped for a kind of machines. So this is the main difference. And then we go to the literature. That is why we identify CM to be the core concept. The reason is that we have checked most important and effective elements to JIT success summarized in the literature, and we put all these elements on this image, on this figure. And we found that when we move cellular manufacturing to the center, we found that it can be supported by one of the elements, or it can produce the other elements, and it can cover all the elements that are listed in the literature, which are reported to be the most important and effective ones to JIT success. And here we group the elements into 1, 2, 3, 4, 5, 6 groups. And we will introduce why cellular manufacturing can produce or be supported by these elements in each group. First is the inventory and lead time. So this one, and then we will explain respectively about these groups. So if we use the functional layout, the vehicles will move goods in batches, so it produce the ingoing queue and outgoing queues in every department, that is every area. And we need warehouses for intermediate products. This makes the inventory to be large and lead time to be long. But in the cellular manufacturing layout, the materials or jobs, they are moved piece by piece, and this makes the queues to be little, and we do not need warehouses. Then the inventory will become low and lead time will be short. And next we talk about quality. The functional layout manufacturing system needs frequent movement, and this will cause some scrapers on the products. And these scrapers or some damage to the products, they are slight, so they may be unnoticed until the final examination. Then when it goes to the final examination and is found, it becomes difficult to know where the cause is, because it is already maybe far from the cause. So the defective rate will be high, and it is hard to reduce the defective rate because it's difficult to trace. But in the cellular manufacturing layout, there is much less movement because every step is very close to each other. So the damages or scrapers will be much less, and we can see where the cause is, and it is easy and quick to find and quick to fix. So the defective rate will be low, and it is easy to reduce the defective rate. And then is about management and scheduling. The functional layout is very complex because the routes are mixed. So we need complex planning, time-consuming scheduling, and adjustment and coordination. So we need expensive planning system, and it's difficult to carry out communication and coordination. But in cellular manufacturing, there is much less information in a cell, so the control becomes simple. For example, we can use compound to make lot sizes visible, and coordination also becomes easier because people can talk close to each other via conversation. Therefore, the control system becomes low in price, and it is easy to carry out fast communication. Then about production cost. When we use the functional layout, the inventory is large, and there are frequent material handling, late rework, high planning and scheduling cost, high management labor cost. So all these add up to high production cost. But when we use CM, there will be low inventory, less material handling, less and early rework, a low planning, scheduling and management cost. So this will significantly reduce the production cost. Next, about worker performance. In the functional layout, workers are narrow-skilled because they can only do one kind of works. So they have little sense of achievement, and they are only muscle power. Then they do not care so much about quality because their responsibility is not quality until the final examination step. So this makes the worker performance to be poor, and there is little worker force flexibility because one worker is only available to do one job, one kind of job. However, in the CM manufacturing systems, workers are broad-skilled. They have a sense of achievement because they can make one product by one individual by himself. So the workers may have pride and higher responsibility, and they can use human intelligence to fix problems because they are responsible for many, steps. They can check where the cause is and how to fix it, and they can communicate as a team. They are not working alone. So the worker performance may be superior to this kind of manufacturing system, and there's high workforce flexibility. And next is about customer service. In this system, the customer service, because it's infrequent delivery of large volume products, so the customer service customers may need to wait, and it is difficult to produce low volume customized products because each group of machines produce a large batch, then the cost can be low. Otherwise, the cost will be high, and this makes the lead time to be long and the response to be slow. But in the cellular manufacturing systems, it can produce low volume production without holding much inventory. So it is easy to produce low volume customization products, ensuring lead time and quick response. And CM is also supported from some elements, including standardized operations and preventive maintenance, JIT education strategy, which can make the lead time shorter and the response quicker. And these elements are all included as the elements point out to be the most important to JIT success. So each point represents one element of JIT success, and we explained why they are all related to CM. So the conclusion is that the analysis justifies that CM either brings or is supported by the most important elements to JIT performance. It has a big positive impact on JIT and is a good start point for adopting JIT manufacturing. And our analysis clarifies the benefits expectable from transforming to CM from the functional layout, typically job shops. And for the scope of application of this conclusion, mostly it is applicable to functional layout systems, and such systems most of them are used to make low variety, high variability production. So for such kind of systems, CM will be a better choice, and perhaps a much better choice to output JIT or lean manufacturing effectiveness. And that is all for our presentation. Thank you very much.